Hello and welcome to today's podcast. I'm Darian Macy, and today we have a very special guest joining us. Leigh Carnall is founder of Civiltech, a cutting-edge company revolutionising the way we approach road inspections with a unique combination of advanced sensor technology and AI data processing. I'm really excited to learn more about his journey and the challenges he's faced and the future that he sees for opportunities with Civiltech. Welcome to the podcast, Leigh.
Thank you, Darren. Thanks for that great introduction. G'day to all the listeners out there.
Can you tell us, let's start by telling us a bit about your background and what inspired you to start Civiltech.
Civiltech has been around for the last 13 years. We've existed as a civil engineering consultancy, delivering civil infrastructure like tailing dams, roads, airfields. We've been a part of helping our clients deliver those projects. We're pretty passionate about being able to deliver value for money projects.
Talk to us about this new evolution with civil AI. What is the problem that you see in the market that this is intending to solve?
Yeah, so civil engineering is, we still rely on a lot of very old technologies and systems and processes for that. And I see that the advent of AI can really take the number crunching and the more mundane aspects of civil engineering to a much higher level. I think back to when I started back in my civil engineering experience with a local council in Wheatbelt, Western Australia. My first 6 months was driving the roads, doing roads inspections, and it doesn't take that much to figure all that stuff out. And very soon, it's really just a drive around looking at roads, and I do think that today's shortage of engineers, there's much better things that we can be doing.
So you're saying there's rules and then repetitive tasks that can be automated?
Yeah. Let's leave the analysis to the civil engineers. The data collection can be done by someone already driving the road network. Let's leave the analysis and the engineering thinking that's required to come up with those solutions. Let's leave that to the humans.
Right. Okay. So can you show us some examples of how your technologies have been applied so far?
Civiltech Solutions has investigated Civil.ai, CYVL.ai, based out of Boston in the US, and their story is really cool. These guys are a startup. The three founders were students at the university who graduated robotics class during COVID, so they found themselves with access to some very high-tech technology and a lot of time on their hands during COVID. So they were able to put these bunch of robotic sensors together, strapped them to the back of their mum's car, and collected some data around that data through AI, and found that they could reliably detect potholes and cracking in the road pavement. And 3 years later, they're now well and truly established in the States. So now they're not only able to detect the potholes, they're able to detect the rutting and the bird bathing, as well as map the entire roadway. So being able to pull from that data the line marking, the curving, and condition rate those elements, all the signs in the roadway, bins, parking meters, anything there that's repeatable running down the road, these guys are able to pull out. These guys have the right mix of robotics and flexibility to be able to deliver the products there that I could see customers would want, whether they want to collect information on the street trees or on their curbing or on their footpaths, or that kind of thing. Around about 12 months ago, we penned an agreement there, and we spent the last 6 months Australianising this process. So we've been able to collect over 3,000 kilometres of road network, and that's been ran through AI to ensure that the models can be reproducible here in Australia. And we're now on the cusp of getting it out commercially around Australia.
Oh, fantastic. Okay. Can you show us some examples on the screen?
Okay, so here we've got in Darwin here, and we've been able to pull up information here on the roadway. So this has all been automatically mapped via the AI. So we've used a sensor, ran the streets, and being able to pull up and process that information through our. So here, for instance, we've got the curb. It's detected that curb, and it's detected the curb everywhere where we've driven. So that means exactly where the islands are and the edge of the curb have been able to do that. Now that is also condition rated as well too. So the sidewalk, for instance, we can pull up the footpath, and we've got a condition rating down here of good as well too. Likewise for the line marking. That's been able to be condition rated. The left turn arrows also in on the mix. So pavement markings. Okay, so on the defects, so the defects here is cracking. So the cracking has been able to be pulled out from the pavement.
And I can see this is a web page. So you're streaming this information from the cloud, are you?
Yeah. So the information here lives on the cloud, and we
so
are
it could be
able
accessed
to,
by anyone who you chose to give access to. Could come in and use this data set. It's not limited to one laptop or one location.
It's not limited to a piece of software there that you need to learn specifically how to use. It's designed to be easy to use, and you're getting the information back there that you might need to do something with. So, for instance, we're able to, let's look at the crocodile cracking there, where there's near areas there where there's potholes, depressions, and bumps and sags. So we can see there's some alligator cracking here on Gardner Street.
So as soon as you click on it, it zooms to that area and shows you a perspective. Yeah, excellent. Wow.
Yeah, that's right. So we've been able to highlight the alligator cracking, the crocodile cracking around that area, as well as the transverse cracking in that area. So what this means is we now have a lot of detail on the pavements, and what we end up doing is scoring the pavement, which is really handy for understanding what's happening. So you can see here this,
like calibrating
these levels,
the condition.
Well, what that means is we can very quickly see the worst areas of our pavement. So you can see here that the pavement either side of these sections are green. They're relatively good, 78, 89. But then you've got these areas here where there's some cracking and some potholing, and you can see it in the screen. So what this means is those 10-metre increments there have been scored and marked down. We're at 57. That's a
so
score
depending
there
on the
for
client's
57.
budget, they could prioritise their spending towards the worst areas.
Yeah, exactly. And you've got that level of granularity, so that if you're having to justify what you're spending, you can say, well, we're only going to spend it on, these are the worst areas, and by the way, these are the sections that make up these worst areas. This is the reason why this section of pavement got such a low score is because of.
And you can do measurements.
Cracking.
So you could give this to a civil contractor, could you, just to do takeoffs?
Yes, yeah. There's a lidar module associated with it. So yeah, we have great resource for being able to do measurements on the platform.
Yeah, wow, fantastic. So what's left? What level of design is left to do from between this and going to tender?
Yeah, so we can see that this is a very good tool for engineers to be able to do the analysis and understand what's happening with those pavements. So you can triage the defects into low, medium, and high severity, so that you're of course wanting to spend money where best bang for buck is. So you can spend it on triaging those that have a safety impact first. Then you can start to spend it on areas of pavement there that are particularly bad, say in the red areas and the deep red areas there, to be able to understand what's actually happening there. So if we were to bring up some of this crocodile cracking in this pavement here, you can start to go, well, the pavement's a bit misshapen, it's heavily cracked, it's at an intersection. Yeah, we need to devise a way of coming up with a remedy. So that's typically what an engineer might have, and you can already see in this you've got some patching that's already occurred. You've got a manhole there that has to be tied into. You've already got dimensions in the LiDAR point cloud. So very quickly, someone experienced in pavement engineering can then start to go, well, this area here needs to be milled out and an asphalt patch or some other remedy applied. So what you're doing is, instead of going from a paper-based form that might have a score of this 10-metre section with 1 to 5, you've actually got photos, you've got markings on a map.
You really don't need to go back to site at all, do you?
No, and in fact, the engineers or those making those decisions wouldn't even need to go to site. The sensor could be put onto another vehicle or someone else that's already driving that segment.
Right. So there's no qualification needed to drive this sensor at all.
And that's exactly right. And, it's designed. Yeah, it's designed to be to be easily placed on top of the car. It has it does its own checks, and
fantastic.
As long as it's got 12-volt power, it'll collect that data and it gets uploaded to the cloud for the civil algorithms to work its magic. And what you're seeing on the screen there is the result of repeatability and accuracy on those outputs. So being able to map those curves gives you very good indication of areas that might need to be paved. You can already see there that on the map there is this manhole cover. So if you were designing, like I said, an asphalt overlay to remedy this area here, or to mill and fill, that you've got some levels there you need to match in around. So might have to be a little bit of pavement work around those manholes.
You got the coordinates of all those features. Yeah, great. So how much effort is involved in going from passing over this with a vehicle with the sensor to having this on your screen? What's the effort required, and what's the time required?
Depending on the outputs there that you might want. Some customers may only want pavements. Other customers may want signs and line marking. And so we have a menu there with which customers can choose from. Typically, the data comes back in around 2 to 3 weeks. So now Civil in the States, for instance, are able to turn data around in less than 24 hours because the models are getting higher and higher confidence levels.
Wow. What feedback have you received so far from the market?
Yeah, very positive. There is a huge amount of need for this in local government. It's about consultants being able to deliver for their customers a much better product using much better information, much more repeatable information. So we're really happy to work with other consultants and customers likewise, of course, to be able to get this information there, and even contractors as well too. There's even been some interest there from contractors wanting to do such things as line marking pickups and dilapidation surveys prior to them moving into an area.
And what are some of the biggest challenges that you're facing bringing this to market?
The magicness of it, in terms of it does feel a bit surreal when I'm talking with customers, particularly the level of information we can provide, like what's on the screen, in terms of moving from customers that are still marking up defects on paper, and perhaps the most advanced thing they've got is a digital camera or an iPad, and now being able to use a robotic sensor that's come from down the road from Boston Lab kind of mentality, and using AI and machine learning to map it. There's a little bit of incredulousness about it, but that's okay. We're happy to step customers through that process and show them there that this is real, this is repeatable, this is accurate information that we can give them.
Yeah, and I can see privacy could be a concern as well. How does it tackle that dimension?
Yeah, with privacy, the first step is to blur out vehicles, and you'll see that it's not just the number plates; it's the entire vehicle that's blurred out, and any people there that are recognised, that is also blurred out as well too.
Wow, and that all happens automatically. That's not somebody sitting there with a virtual eraser. That's actually
virtual. Yeah, that's the machine. That's the very first step. As soon as the data's uploaded, that kind of information is scrubbed.
Okay, so what opportunities do you see for this technology in the defence sector?
Managing infrastructure, pavement, roadways, assets, is a big task for any organisation, and defence is one of those organisations with a lot of pavement and roadway assets. This is a sensor that could be put onto an airfield and be trained on an airfield, for instance. The flexibility is there to train it on other aspects.
Just to finish off then, Leigh, what's your vision for the growth of Civiltech in the next 5 years?
We're very keen to incorporate more of this technology into the civil engineering space. We're very interested in developing solutions based on the back end of this technology, based on the outputs that this can produce, and having civil engineers in that loop. So being able to make best use of an engineer's time to analyse and actually provide some good advice based on some really good data, and ultimately having financially sustainable infrastructure is the primary motive for our customers.
Fantastic. Tell us a bit about yourself. So you're Darwin based now?
Yeah, Darwin based. Was originally from the southwest in Western Australia. So I grew up in the southwest of Western Australia, Bunbury boy. My nana has a connection with Yamaji out of the Midwest. From Geraldton way, that way, and I was a defence reservist for 8 years in the Greens, 11, 28, 42, 12, 40.
Thank you very much, and congratulations on getting this far. I just can't wait to see where this takes you. Thanks again for joining us, and we'll catch you next time.
Thanks, Darian. Thanks, everyone.